Welcome to Year 7 Science. My name is Gabrielle and this is Lesson 1 in our unit on mixtures. What is a mixture? Let's take a look at our lesson objectives first. To define suspension, solution and colloid, to determine the difference between soluble and insoluble, and to create a mixture. Let's begin our lesson with a starter activity. Here is a picture of some Smarties chocolate candies. They are a mixture of ingredients. Make a list of the ingredients they might contain. So take a moment to pause this video and make a list of some possible ingredients that you might find in these chocolate candies. For example, food colouring. So take a moment to pause the video and do that activity in your notebook. When you're ready to check your answers, restart the video. Welcome back. Here are the answers to our starter activity. Possible ingredients include sugar, chocolate, butter, oil, wax, which gives them that shiny appearance, food colouring, and milk. How did you go? Did you write down any of those ingredients? Let's get into the main part of our lesson now. What is a mixture? All natural and manufactured materials on Earth can be put into two categories, pure substances and mixtures. For example, air. Air is a mixture of different gases, nitrogen, oxygen, carbon dioxide, and other gases. A mixture is a combination of two or more substances. Each substance has its own properties. A pure substance is a single substance. We will learn about three different types of mixtures: solutions, suspensions, and colloids. Solutions. A solution is a mixture that contains one or more substances, the solute, dissolved in another substance called the solvent. The solute must therefore be soluble, so it must be able to be dissolved. Solutes can be solid, liquid, or gas. Solvents are usually, but not always, liquid. For example, take a look at this picture of a glass of fizzy cola. Carbon dioxide gas, which gives it the bubbles, and solid sugar and some food colouring and other flavourings are dissolved in water, and this forms the basis of our fizzy drink. Furthermore, solutions that contain water as the solvent are called aqueous solutions. So this glass of fizzy cola would be called an aqueous solution. More on solutions. Now, concentration, when we talk about solutions, is the ratio of the solute to the solvent. For example, have you ever had cordial that is too sweet? That's because there is too much cordial syrup, called the solute, compared to the water, called the solvent. Now, the ratio of syrup to water in cordial differs according to your taste, so it is not a set ratio. Now, some substances like pesticide or washing liquid need to have the substances or the solutes in the right concentration. Otherwise, the mixture won't perform as intended. So you might have noticed if your washing liquid is almost run out and you sort of top it up with a bit of water, it kind of loses its effectiveness as washing liquid because it's less concentrated. So that would be an example of a solution which is not in the right ratio. So washing liquid that is kind of a little bit diluted is not as effective as washing liquid straight out of the bottle. The next kind of mixture is a suspension. A suspension is a mixture that contains visible insoluble particles in a liquid. Now, if left to stand, the particles in a suspension sink to the bottom of the container and they form a layer called sediment. And sometimes they will float to the top, as you can see in this example of a suspension, which is mud suspended in water. Now, suspensions tend to be cloudy since there are some solids or solutes that have not entirely dissolved. So some of them will dissolve. That's why you've got this sort of cloudy brown liquid in the middle. Some of them are light enough that they'll float to the top, and some are heavy enough that they'll sink to the bottom. So that is an example of a suspension. Now more on suspensions. Milk is an example of a liquid suspended in a liquid. So if you let fresh milk come straight from the cow sit in a container or in a bottle or whatever on the bench, it will separate into layers and you get cream on top and skim milk underneath. So have a look at this photograph here. We've got two jars. The one on the left with the silver lid is something called homogenized milk, which is not separated. And we're going to learn more about the homogenization process a little bit later in our lesson. But the jar on the right contains milk that's come straight from the cow. And if you leave it long enough, it has separated into some creamy, buttery solids on the top or semi-solids on the top. And you've got this sort of watery, white whey protein liquid, skim milk liquid at the bottom. Now, the last example of a mixture is a colloid. So the particles of one substance in a colloid solution are spread evenly throughout the other. For example, some kinds of muddy water have particles that are not soluble, but they're not heavy enough to sink to the bottom. So they're kind of just the right size to be suspended evenly throughout the solvent. Now, solutions, on the other hand, are clear, but colloids are not. And this is because the light is scattered by larger particles within the mixture. Now, more about colloids. An emulsion is formed when one liquid is spread evenly through another liquid and does not settle in a layer. So remember the milk? Non-homogenized milk is a suspension, which is a form of colloid, because its parts will settle over time. But homogenized milk is an emulsion, which has been treated with an emulsifying process. And this is where the milk is passed through a small passage at high speed. And this forces the cream, or those buttery, creamy sort of lumps, to break up and spread evenly through the skim milk base. Now, some emulsifiers are chemical and some are physical, like the milk, for example. So going back to our picture we looked at earlier, we can see that the jar on the left is homogenized. So it's an emulsion. And the jar on the right is a suspension because you've got some bits of cream and stuff suspended at the top, and then you've got the whey and the protein and the skim milk bits suspended at the bottom. Now, there are several other types of colloids which we're going to look at now. So emulsions are a type of colloid mixture, but there are some other examples. So I'd like you to pause the video in a moment so you can copy this table into your notebook. But let's just go through the table first. So in the column on the left, we've got the type of colloid listed. The middle column, we've got the type of substance that it's suspended in. And then you've got some examples of colloid mixtures. So first of all, we've got an emulsion, which we've learned about, which is a liquid in liquid. Examples include homogenized milk and mayonnaise. A sol, not short for solution, it's a type of colloid, which means a solid suspended in a liquid. For example, murky brown creek water. So some solids are suspended in the liquid, some of them sort of mix through and just sort of float around and give it that brown color. Some of them float to the bottom, they'll sink to the bottom, and some of them float on top. Foam, this is a gas in a liquid or a solid. For example, hair mousse, marshmallow, or like that sort of foaming hand wash that you can pump out into your hand. That's another example as well. And an aerosol. An aerosol is a liquid or solid in gas. So you might have a can of gas and it's got some liquid deodorant or air freshener or fly spray, or some solid particles in a gas. So examples include fog or smoke, but I've also mentioned hairspray or fly spray, some other examples as well. So pause the video now and copy that table into your notebook if you haven't done so already. If you have, let's continue on to the activity. Okay, so let's have a look at this picture here in the center of the slide. What you need to do is to label the picture with the correct terms A to C. So the terms are colloidal or colloid, suspension, solution. So we've got 3 beakers, got A on the left, B in the middle, and C on the right. So have a look closely at these types of mixtures. And in your notebook, I want you to write A, B, and C, and then write the name of the mixture next to A, B, and C. So is the mixture a colloid, a suspension, or a solution? So pause the video now while you complete this activity in your notebook. When you're ready to check the answers, restart the video. Welcome back. Here are the answers to our activity. So you can see there that I've got the answers underneath. So A is a solution because it's clear, you can see through it, like sugar water or salt water, for example. B is a colloidal, so everything's kind of like mixed very evenly through the liquid and it's quite cloudy, so you can't see through it. But a suspension, on the other hand, you've got some sediment at the bottom, or sometimes you'll have a little bit of stuff floating at the top, but it's not mixed in. So you've got this kind of cloudy, murky water, a little bit clear, a little bit not clear, and you've got a whole bunch of stuff at the bottom. So it's definitely a suspension. Well done if you got those all correct. Okay, so we're going to watch this video now, which recaps what we've learned in our lesson so far. You're welcome to take notes if you want to, because there's going to be some questions after the video. Let's watch.
Summertime is picnic time with sweet iced tea and yummy fruit salad. And ants. But still, yummy fruit salad. And hey, did you notice something? Those foods have something in common. They're both mixtures. Things made by combining 2 or more different things. Not the ants, they're just ants. But the iced tea and the fruit salad are mixtures. Anytime you combine 2 different things, you make a mixture. Whether it's strawberries and bananas, raspberries and blackberries, or cantaloupe and Legos. Which I don't recommend eating at all. I'm just saying it's a mixture. So let's have a little science with our picnic, shall we? Let's talk about the different kinds of mixtures we can discover. For example, if we mix sand and water in a glass, we'll get a mixture, even though after a while the sand will settle to the bottom of the glass. But if we stir some sugar into the water, the sugar looks like it disappears. But it really doesn't. The particles that make up sugar become distributed or spread around evenly among the particles that make up water. We call this kind of mixture a solution. Solutions have 2 main parts, the solute, which is the stuff that dissolves, in this case the sugar, and the solvent, which is the stuff in which the solute dissolves, in this case the water. Now, solutions can be made from types of matter that are in different states too. For example, the air that we breathe is made up of a solution of gases, mostly nitrogen, oxygen, and carbon dioxide. And soda water is really a solution of carbon dioxide gas and liquid water. But no matter what, and this is important, mixing things together in solutions does not make a whole new substance. Solutions can be separated again, back into the substances that made them. So, for example, if you leave the lid off a bottle of soda water, the carbon dioxide that's dissolved in the water will slowly float up to the top and bubble away. Given enough time, you'll be back to having plain old water in the bottle and carbon dioxide in the air as 2 separate things, not mixed together. So when you take a sip of your favorite fizzy drink, you're drinking a solution. But not all substances dissolve easily into other substances. The ability of something to be dissolved is called its solubility. Sand doesn't dissolve in water, for instance, so we say it has low solubility in water. But sugar dissolves pretty easily, so sugar has high solubility in water. Still, no matter how easily something might dissolve into another thing, you'll eventually reach the point where it can't dissolve anymore. Let's say you pour a whole bunch of sugar into a small glass of water. If you keep adding sugar to it to make it even sweeter, and who would blame you for trying, you'll get to a point where no more sugar can dissolve. The extra will just sit at the bottom. This is called saturation, the point at which no more solute can dissolve into a solution. Saturation happens when there's just no more room for the particles that make up the solute, in this case the sugar, to squeeze between the particles of the solvent, the water. Whew! All of this is making me snacky. Let's check out our picnic table again and investigate the different kinds of mixtures we see there. Let's start with the fruit salad. That's definitely a mixture of different kinds of fruit. Is it a solution? Nope, because the particles that make it up aren't equally distributed. I can dip my spoon in there and come up with nothing but strawberries one time, and then go back for more and get a spoonful of only bananas. How about the sweet tea? The solution to that question is that it's a solution. Particles of, say, water and sugar in the tea are evenly distributed in the glass. Every bit contains water and sugar. They're spread out evenly. Now, can the substances that make up our iced tea solution be taken apart again? Yep, if we heat the tea so that the water in the solution changes from a liquid to a gas, it evaporates into the air, leaving the sugar behind. So let's go over what we learned at our little mixed up picnic. A mixture is made by combining two or more substances. When the particles that make up the substances are equally distributed, the mixture is called a solution. Solutions can be made of substances that are in the same state of matter, like gases in the air, or in different states of matter, like the gas bubbles in soda. The solute is the part of the solution that is dissolved, and the solvent is the part into which the solute dissolves. And solutions and some other kinds of mixtures don't always make new substances, even though it might look that way. Now, let's enjoy what's left of our picnic before the ants carry it all away.
Okay, let's take a look at our video questions now. 1. A solute is A, a substance that dissolves in another substance, B, a substance in which another substance is dissolved, or C, water. And question 2, a solvent is A, sugar, B, a substance in which another substance is dissolved, or C, a substance that dissolves in another substance. So pause the video now and complete the answers to those two questions in your notebook. When you're ready to continue on to the next questions, restart the video. Welcome back. Here are questions 3 and 4. 3. Sugar has A, low solubility, B, no solubility, or C, high solubility. And 4. Sand has A, low solubility, B, no solubility, or C, high solubility. So again, take a moment to pause the video and complete the answers to those two questions in your notebook. When you're ready to check the answers to all 4 questions, restart the video. Welcome back. Here are the answers to questions 1 and 2. 1. A solute is A, a substance that dissolves in another substance. For example, sugar. Sugar is a solute because it dissolves in water. And 2, a solvent is B, a substance in which another substance is dissolved. So thinking about our sugar water example, if sugar is the solute, then the water is the solvent. And the answers to questions 3 and 4 are 3, sugar has high solubility, because when we dissolve sugar into water, it pretty much almost disappears. So it makes a solution, which is clear. And 4, sand, on the other hand, has low solubility compared to sugar. Did you know Robert Boyle, who was born in 1627 and died in 1691, was an Irish aristocrat or a member of the sort of noble family. And he defined elements, compounds, and mixtures. So what we know about mixtures comes from Robert Boyle's research. And he also coined a new term, chemical analysis, which was a field in which he made several powerful contributions. Okay, so we're going to have a look at an experiment now, which will help you determine the solubility or insolubility of some common substances. So substances that dissolve are said to be soluble, and those that do not are insoluble. So this experiment investigates the solubility of some common substances in water. So first of all, I'd like you to pause the video now and copy this table into your notebook. So you should have 3 columns. The first column is substance mixed with water. The middle column, clear or cloudy. And the third column, solution, yes or no. Now the substances are in the column on the left. So we have salt, sugar, flour, coffee, sand, copper sulfate, and copper carbonate. Now the last 2 substances you could only obtain in a chemistry kit, or if you were doing this experiment at school, or if you had access to a laboratory. If you don't, you can just leave those out and just do salt, sugar, flour, coffee, and sand, or soil if you've got a garden or maybe some pot plants that you can use. All right, so pause the video now and copy that table into your notebook, and when you're ready to continue on with the experiment, restart the video. Okay, so for this experiment, you're going to need the following pieces of equipment. Now, if you're doing this experiment because you have access to some chemicals, like in a chemical kit, or maybe you can have access to a school laboratory, you'll need some safety glasses because the copper sulfate and copper carbonate, you will need safety glasses for those. A laboratory coat or just some kind of apron so you don't get any sort of some substances on your clothing. A heat-proof mat or some kind of stable mat where you can put your containers. Now, if you've got a chemistry kit at home with some test tubes and a test tube rack, that's awesome. If you don't, you can just use some glasses, so just normal kitchen glasses for drinking out of, or cups. You can use those instead. And you'll need a spatula or something very small, like a teaspoon, which you can scoop the substances into your water. So our substances are salt, sugar, flour, coffee, sand, and if you can use copper sulfate and copper carbonate. So here is the method. So you need to half fill each of your test tubes or glasses with some cold water. Just water out of the tap is fine. And you should have some little labels or some sticky notes, if you like, which labels each container with what goes inside it. So salt, sugar, etc. Now, then you need to go and spoon your substances into each container. Give it a bit of a stir and then hold it up to the light. So after you hold it up to the light, is it cloudy or is it clear? And then I'd like you to record your results in the middle column of your table. And then once you've recorded your results, decide whether each mixture is a solution or maybe a suspension. And you can record your results in the table. So I'd like you to go ahead now and conduct this experiment. Now, if you don't have the time or you don't have the equipment, you can kind of have a bit of an estimate or a bit of a guess at what would happen if you were actually to conduct the experiment, and have a go at doing that. So pause the video while you have a bit of a guess and fill in your table, or actually do the experiment. And when you're ready to compare your answers, restart the video. Okay, welcome back. Here are the answers to our experiment. So as you can see, we've got, starting with salt, when you stir, say, a teaspoon or a small amount of salt in water, you're going to get a clear solution. So yes, it is a solution because it's clear. So there's no little bits of salt floating around. Same for sugar. Sugar, like salt, dissolves in water, so it gives you a clear solution. Flour, on the other hand, gives you a cloudy solution. So it would be a colloid because flour will actually mix into water and it will form a colloid mixture because the tiny bits of flour will like float around and it'll become quite thick, a bit like glue. But it is still a colloid because it's kind of suspended in there and you can't see through it. It's cloudy. So no, it's not a solution because it's not clear. It's actually a colloid. Coffee, on the other hand, now this is a bit of a tricky one. If you have instant coffee, then yes, it will be a clear solution. Now it'll be brown coloured, but you should still be able to see through the liquid, the solution. And so yes, it is a solution because it dissolves. Now, if you use coffee grounds, like the coffee that you put in a coffee machine, then that is not a solution. That is a suspension because the coffee won't mix into the water properly and bits of coffee will kind of sink to the bottom. So depending on the coffee you use, it will determine the results that you get. Sand, definitely cloudy, and it'll be cloudy for a while, but then the sand will slowly sink to the bottom, and that's called a suspension because it either little bits of sand or material might float on top of the water, but most of it will sink to the bottom. So that is definitely not a solution. Copper sulfate is a solution. It'll give you a clear blue color. So yes, it's a solution. And copper carbonate cannot dissolve in water. So it'll be a little bit cloudy for a while and then it'll become like a suspension and it'll just sink to the bottom. So no, it is definitely not a solution. How did you go? Did you get any of those correct or all of them correct? Well done if you did. All right, well, that brings us to the end of lesson 1. What is a mixture? Thanks for watching. Don't forget to check out our website, voyagerschool.com.au, for more valuable courses in more subjects for high school students. See you next time.